Introduction to Calculus. Limits. Problems concerned with rates of change can be investigated by using a branch of mathematics called differential calculus. Differential calculus is defined in terms of limits. For example, if f of x equal to x squared as x, that arrow 2 read as x approaches 2. A limit is the value that a function approaches as the input approaches some value. We look at some examples. Question 1. Find the limit of f of x equal to 2x minus 5 as x approaches 3. So these questions are solved like the way we solve functions, where we have the values of x, which are the domain, and the values of y, which are the range. So what we are supposed to do is just to substitute the values of x in the equation to solve for f of x. So we are going to say f of x equal to 2x minus 5. Where there's that x, we are going to substitute a 3. So we'll say f of x equal to 2x minus 5 as x approaches 3 is the same as 2. Open your bracket 3, close your bracket, minus 5. 2 times 3 is giving us a 6. 6 minus 5 equal to 1. We go to question 2. Find the limit of f of x equal to x squared as x approaches 2. So where there's that x, we are going to substitute a 2. So we are going to say f of x equal to x squared as x approaches 2. It is the same as 2 squared. 2 squared is 2 times 2, which is giving us a 4. Question 3. Find the limit of each of the following. We have the limit x squared minus 9 over x plus 3 as x approaches 3. Now, x squared minus 9 is a difference of 2 squares. We can always express this 9 as 3 squared. So we are going to say x squared minus 9 divided by x plus 3 is the same as x squared minus 3 squared over x plus 3. When you are given a difference of 2 squares, it's the same as getting the difference of the bases times the sum of the bases. So that is giving us x minus 3 times x plus 3. X plus 3 is a common factor. We can always divide x plus 3 into x plus 3, which is going to give us a 1. So we'll remain with x minus 3. So we are going to say x minus 3 as x approaches 3 means we are supposed to substitute a 3 where there's that x. It's giving us 3 minus 3, which is the same as 0. Part B. Find the limit of x squared plus 5x plus 6 over x plus 3. X squared plus 5x plus 6 is a quadratic expression. So we are supposed to find two factors such that when we multiply them together, they must give us a 6. But when we add them together, they must give us a 5. So those factors are 2 and 3. So we are going to rewrite 5x using those factors and then factorize by grouping the terms. So we are going to say the limit of x squared plus 5x plus 6 over x plus 3 as x approaches 3 is the same as the limit of x squared plus 2x plus 3x plus 6 over x plus 3. We have rewritten the 5x as 2x plus 3x. Then we can factorize by grouping the terms. So when we factorize, we are going to get x plus 2 and x plus 3. X plus 3 is a common factor. X plus 3 into x plus 3 is giving us a 1. So remain with x plus 2. So we are going to say the limit x plus 2 as x approaches 3, where there's that x will substitute with a 3. So we are going to say 3 plus 2, which is giving us a 5. Question 4. Find the limit of each of the following. We have the limit 3x minus 4 as x approaches 4. Where there's that x, we are going to replace a 4. So we are going to say the limit of 3x minus 4 as x approaches 4 is the same as 3, open your bracket, 4, close your bracket, minus 4. 3 times 4 is giving us a 12. 12 minus 4 is equal to 8. Part B. Find the limit of 5x plus 10 as x approaches 3. What we are going to do is to replace a 3 where there's x. So we are going to say 5, open your bracket, 3, close your bracket, plus 10. 5 times 3 is giving us a 15. 15 plus 10 equal to 25. Question 4c. Find the limit of each of the following. X squared minus 16 over x plus 4 as x approaches 4. So this one is also a difference of 2 squared. Where there's that 16, we'll replace it with a 4 squared. So we are going to say x squared minus 16 is the same as x squared minus 4 squared. Then we'll get the difference of the bases times the sum of the bases. So that is giving us x minus 4 and x plus 4. X plus 4 into x plus 4 is giving us a 1. We'll remain with x minus 4. So say the limit of x minus 4 as x approaches 4 is the same as, where there's that x, we'll replace a 4, which is giving us 4 minus 4, which is equal to 0. Part D. Find the limit of x minus 2 over x squared minus x minus 2 as x approaches 2. So our denominator is a quadratic expression. We are supposed to get two factors or two integers such that when we multiply them together, they'll give us a negative 2, but when we add them together, they'll give us a negative 1. So our factors are positive 1 and the negative 2. So where there's that negative x, we'll replace it with a positive 1 and the negative 2. So we are going to say x minus 2 over x squared minus x minus 2 as x approaches 2 is the same as x minus 2 over x squared plus x minus 2x minus 2. Then we'll factorize by grouping terms. Our common factor is x, and then we'll open our brackets, x plus 1. Then our common factor there is a negative 2. So it's going to look like that. So we are going to say x minus 2 over x plus 1 over x minus 2. X minus 2 is a common factor. X minus 2 into x minus 2 is giving us a 1. So we'll remain with 1 over x plus 1 as x approaches 2. Where there's that x, we'll replace it 2. So we are going to say 1 over 2 plus 1, which is giving us 1 over 3. As simple as that.